afternoon, children. Welcome back to our online class. I hope that you all are safe at home, right? Yes. Are you all happy? Yes. Do you have interest to revise the lesson? Yes, is it? Today we can revise what we learned in the previous classes. That is for the test, the portion which we have taken, that portion we can revise today. Okay. So once we can recall everything that which we have for the test. Okay. As shortly. See, chemicals and chemical changes, is it? Our lesson topic is chemicals and chemical changes. So first we have learned about chemicals. Then, so for that we have seen what is chemical substances. Chemical substances. Chemical substances are made of atoms and molecules. Chemical substances are made of atoms and molecules. Then what is that atom? An atom is the smallest particle of a substance. Is it? Okay. So atoms may or may not exist independently. Atom is the smallest particle of a substance. Then molecules means, what are molecules? Molecules are formed when two or more atoms join together. Molecules can exist independently, is it? Then chemical substances, it is divided into two major groups, is it? So what are they? Pure substances and mixtures. Pure substances and mixtures, is it? Yes. Now, pure substances, again it is classified into two. That is element and compound. Pure substance, again it is classified into two, element and compound. See, then what is that element called? What is an element? An element is a substance that is made up of only one kind of atoms and cannot be broken down into simpler substances by chemical means. An element is a substance that is made up of only one kind of atoms and cannot be broken down into simpler substances by chemical means. Is it? So what are the examples we have seen? Silver, gold, aluminium, etc. Then what is compound? What is a compound? A compound is a substance that is formed when two or more elements combine chemically. Compound is a substance that is formed when two or more elements combine chemically. Is it? Then we have learned about mixtures. Is it? Mixtures consist of two or more substances simply mixed together but not chemically combined. Mixtures consist of two or more substances simply mixed together but not chemically combined. For that also we have seen examples, is it? Air is a mixture of various gases such as nitrogen, oxygen, carbon dioxide, water vapor, argon, then particles of dust, smoke and many others. Is it? Then we have learnt about chemical symbols. Is it? Chemical symbols. So, why we are using these chemical symbols? Why we are using? Can you say? To write their full names, it would be time consuming, is it? So to avoid this, an abbreviated form has been assigned to each element, is it? So abbreviations used to represent elements are called chemical symbols. The abbreviations used to represent elements are called chemical symbols. Is it? Okay. So first, as chemical symbols, they used pictures. Is it? Pictures. Sir John Dalton, English scientist, is it? He created his own set of pictorial symbols for elements known in his time. Then, after some years, that is Johannes Jacob Berzelius, he is a Swedish chemist. So instead of pictures, he made use of the letters of the English alphabet to represent various elements. Is it? So we have seen important features of the system, is it? So first one, that is first English letter appearing in the name of an element is used as its symbol. So for that examples we have seen hydrogen, first letter H. So H should be capital letter, is it? From the name first letter we used H. Carbon, C. Oxygen, first letter O, capital letter, is it? A symbol we used. Then nitrogen, N, etc. Then symbols of some elements have also been derived from their Latin names. Then second feature, two or more elements have their names beginning with the same letter. One more letter is added to the symbol. For that, some elements, the second letter in their name is added, such as for calcium, C, and the second letter A, Ca. Cobalt, Co. Xenon, Xc. Helium, He. Bromine, Br. In some cases, another distinct letter is used. Example, chlorine, Cl, magnesium, Mg, manganese, Mn, zinc, Zn. Z. So, all those things we have seen before. Now, symbols of some common elements. See the video picture I have shown in the tabular column. It is given. Did you see 4.1? See first element given as aluminium, Al. Symbol is Al. First letter should be capital letter and the second letter should be small letter. So A should be capital, second letter L should be small letter. Okay. Yes. Next, barium, Ba, boron, B, neon, Na, uranium, capital U, calcium, Ca, magnesium, Mg, fluorine, F, gold, Au, mercury, Hg, lead, that is plumbum in Latin name, okay. Pb, iron, ferrum, Fe, chlorine, Cl, nitrogen, N, potassium, K. Why K? It is gallium, is it? That's what potassium, K. Silicon, Si. Silver, Ag. Why Ag? Ag we are using, Latin name is argentum. Then iodine, I. Sulfur, S. Helium, He. Oxygen, O. Sodium, Na. Why Na? Latin name is natrium. Okay. Phosphorus, P. Lithium, Li. Nickel, Ni. Copper, cuprum. This is Latin name. That's what. Cu. Then hydrogen, H. Zinc is a 10. Is it? Okay. So this all symbols you should know. Okay. Then atomicity. What is atomicity? The number of atoms present in one molecule of an element is known as its atomicity. So what is atomicity? The number of atoms present in one molecule of an element is known as its atomicity. Depending on the atomicity, molecules can be monatomic, diatomic, tetratomic. Mono means 1, di means 2, tetra means 4. Okay. So what is atomicity? The number of atoms present in one molecule of an element is known as its atomicity. Okay. So for that also we have seen some examples, is it? So types of molecule is mono, di, tetraatomic, is it? So atomicity for monoatomic molecule is 1, diatomic is 2. Tetraatomic molecules atomicity is 4, is it? Then examples which we have seen for monoatomic is helium, neon, then sodium, potassium. Diatomic means H2, hydrogen, nitrogen, oxygen. Z. Why? Because H2. Z. H2N2O2. 2. Di means 2. Atomicity is 2. Therefore, atomicity is 2. Then tetraatomic phosphorus P4. 4 tetra. Okay. So, atomicity is 4 here. Okay. Then chemical formulae. What is called a chemical formula? The representation of a molecule of a compound using chemical symbols of its constituent elements is called a chemical formula. What is called a chemical formula? The representation of a molecule of a compound using chemical symbols of its constituent elements is called a chemical formula. Is it? Chemical formula of some compounds we have seen before class, is it? So, shall we see some few examples? Water. Water, what's the formula for? What's the formula? H2O. H2O. In the subscript of H2, is it? Then common salt, NaCl. Common salt, that is sodium chloride. Then hydrochloric acid, HCl. Then calcium carbonate, CaCO3. Nitric acid, HNO3. Sulfuric acid, H2SO4. So these are the examples for few compounds. Okay. Then chemical formulae of some compounds. Okay. Then about valency. Valency. What is called a valency? The combining capacity of the atom of an element is called valency. The combining capacity of the atom of an element is called valency. For that also we have seen some elements, valency of some elements, is it? So hydrogen, what is the valency for hydrogen? 1. Carbon 4. Oxygen 2. Chlorine 1. Potassium 1. Iron 2 or 3. Sodium 1. Magnesium 2. Calcium 2. Copper 1 or 2. Nitrogen 3 or 5. Aluminium 3. Is it? So you should know this valency for valency of these elements. Okay, valency of these elements. Then only we can do that some questions in the exercise we have. That is, write the chemical formula for the following compound. Potassium chloride, sodium oxide, calcium chloride, this and all. If you want to find, you want to know this valency. Okay, so learn this. Okay, yes. Now, we can learn fill in the blanks with correct words. You have to answer now. Okay. So, first question. Dash may or may not exist independently. Dash atom dash may or may not exist independently. Molecules are atoms. What's the answer? Atoms may or may not exist independently. Good. Then, dash are formed when two or more similar or different atoms join together. Mixtures or molecules. Molecules, is it? Molecules are formed when two or more similar or different atoms join together. Third one, dash is made up of only one kind of atoms. Element or compound? Element, is it? Then the next question is, dash consists of two or more substances simply mixed together. Mixtures or compound? Mixtures, is it? Then dash is the number of atoms present in one molecule of an element. Atomicity or valency dash is the number of atoms present in one molecule of an element. Valency means combining capacity, isn't it? Here atomicity is the answer. So these 5 questions you want to learn, okay? Yes. So test portion is the page number 51 to 55. Okay, 51 to 55. So only we want to complete writing a chemical formula, that in the next class we will complete. Okay, we will revise that. Also exercise page number 63 and 64. Okay, so almost we have revised everything. The remaining we will see in the next class. Okay, thank you children, thank you all.